Side 2, we have 6 more problems, each more complicated than the last, of course, but we're going to go ahead and knock them out. So, first problem, 2 parentheses y plus 2 minus 4 equals 18. Nothing super complicated about this one. We're just going to go ahead and plug it in the way we did before. So we are going to get rid of these parentheses by distributing. So it would be 2y plus 4 minus 4 equals 18. Okay. My next step is going to be to combine like terms. I have a positive 4 here and a negative 4 here. I'm going to combine those. Okay, and when I do, those are actually going to cancel out and leave me with 2y equals 18. It is now a one-step equation. That one step is to get this 2 away by dividing it on both sides. Divide both sides by 2. Those 2's will cancel, and y is going to equal 9. Got lucky that those 4's canceled out. Everything came out nice and pretty. Number 12 is very similar to number 10, where we have the fraction, so we're going to change it. We're going to put that for x on top of the fraction. Okay. Now, all of our like terms are combined. This is no longer a fraction. Now it's a division and multiplication problem, making it a little easier for us to work with. So I'm going to go to my do and undo chart. Okay. Look at the side with the x. No parentheses, no exponents. X is being multiplied times 5. X is being divided by 2. And we are subtracting 7. So we're going to go ahead and do the opposites of those things. Those are my 3 steps. Add 7, multiply by 2, and divide by 5. Starting at the bottom, we'll add 7, which will give me 10 equals 5x divided by 2. We're going to multiply both sides by 2, which gives me 20 equals 5x. Then we're going to divide both sides by 5, which will cancel that there, and give me 4 equals x. No biggie. Alright, the next problem here. We have more fractions. We're multiplying and solving, but remember, multiplying fractions with 1 on the top is a simple thing to do. You just need to divide each of the terms by the denominator. So it's going to be 6x divided by 2 plus 20 divided by 2 equals 40. Bigger numbers here, but it's not going to matter because our process is the same. 6x divided by 2, 6 divided by 2 is 3 with an x. 20 divided by 2 is 10 equals 40. If we go to our do and undo chart, looking at the side with the x's, I see that we're multiplying times 3 and adding 10. So times 3 plus 10. The opposites of those on the other side. Start from the bottom, go to the top. We're going to subtract 10 from both sides, which will give me 3x equals 30. Then we'll divide both sides by 3, which gives us x equals 10. Next step is going to be, the next problem is very similar. So we have a negative 4 over here, that's going to hang out. We have a 1/7, so we're going to do that. Look, our numbers are big, but they're not going to be for very long. So we're going to have 49a divided by 7 plus 70 divided by 7. So 49 divided by 7, in case you don't know, is 7 with an a. 70 divided by 7, hopefully that one's a bit easier. That's going to give us 10. Now if we look at our do and undo processes, okay, we're going to look at the side with the variable on it, which is a. We are multiplying times 7 and adding 10, so times 7 plus 10. Put the opposites on the other side and work the problem. So subtract 10 first. 10 minus 10 on this side cancels out, leaving me with just 7a. On the other side, negative 4 minus 10 is negative 14. You might want to use your calculator for that one if you have negative numbers or integers you're doing operations with. So that's minus 10. The second step is to divide by 7. Okay, which is going to cancel here. Negative 14 divided by 7 is negative 2, and then equals a. My a's kind of look like 9s. Sorry about that. And the final two problems. Again, we have a fraction here, but it has a 1 on top, so we're going to be good to go. I'm going to put negative 11 over here because we're not dealing with that yet. Over here, 1/2 times negative 4x is negative 4x divided by 2. 1/2 times 10 is going to be plus 10 divided by 2. And then I'm going to simplify these two fractions, or these two division problems. Negative 11 equals negative 2x, that's negative 4 divided by 2. 10 divided by 2 is 5. There's my problem. No like terms to combine, we're good to go. Look at my do and undo chart, no parentheses, no exponents. X is being multiplied by negative 2, so times negative 2. And we're adding 5, so plus 5. The opposite's here. And then work it from the bottom to the top. So we're going to subtract 5 first. Subtract 5, which will cancel here, leave me with negative 2x. Negative 11 minus 5 is negative 16. That's done. We're going to divide by negative 2, which gives me a negative divided by a negative is a positive 8. And then over here, the negative 2's cancel, leaving me with just x. Make sure that when you do this division and multiplication that you use the negative sign. A lot of times problems are missed because the signs are wrong. So make sure that you divide by negative 2 and not just 2. Last problem. We have 8 equals. This 4x is just going to come down because it's not part of what's going on the other side. However, we're going to distribute by multiplying by this negative 2. So negative 2 times 4 is negative 8. Negative 2 times 2x is negative 4x. Okay? Now, for this problem, this is going to get a bit complicated. We didn't talk about that in class, but you'll see. We want to combine like terms. So the like terms I have here are 4x and negative 4x. Now, when I have 4x minus 4x, those two things cancel out completely. It doesn't leave an x. It leaves nothing, a 0. So what I end up with, 8 equals negative 8. Now, this is something we didn't come up with, or didn't do in class, when all of the x's are gone and we have two numbers. There are two possibilities. The first one is that the numbers are different. 8 equals negative 8. In this case, we talked about yesterday how a solution is something that makes a statement true. Now, 8 equals negative 8 will never be true. It's just not true. That is not true. So this question actually has no solutions. There is no number you could plug into this equation that would make a true statement. That's what it means. The alternative is that you have the same number on both sides, same sign and everything, and that means you would have infinite solutions. It means that any number would work for the variable, but that's not what we have here. We don't have this issue on the test, or the quiz, don't worry about it. But that's what it means when all of your variables cancel out and you're left with two numbers. And that's it. Those are my two videos. So good luck tomorrow.